Oh.
Okay, so we should start writing a SystemVerilog code for adder. Okay, here I am writing first the design code for adder. Okay,
Mm.
so module adder input 1, input 2, then sum. Now
Mm.
input 3 down to 0, input 1, input 2, then output 3 down to 0, sum. Then assign sum equal to input 1 plus input 2. Here you can write any logic. I don't have like logic you have
Mm.
studied already in Verilog. You can write your own logic.
Mm.
Okay. Next,
Okay.
what are the things there should be in test bench? First one is your
Mm.
transactor class. So transactor.sv. In the transactor, you have to just declare this input and output. Okay. So why I
Okay.
am declaring it inside a class? Because it is more reusable. Okay. So let's write
Mm.
module. So not module, class TRN transaction. Okay. This transaction class in UVM it is sequence item. Class transaction. Okay. Then range. You can write take bit or logic. It's up to you. Okay. I'm using bit. So 3 down to 0. Input 1,
Mm.
comma, input 2, then logic.
Okay.
You can take here also logic, no problem. Why I have taken logic here? Because let due to some reason your output is equal to X. If you are taking bit here, then you will not
Mm.
be able to get it, because if you are taking bit means its value is 2 valued, will become 0 or 1. If you want to take then X properly, so take logic here. So logic
Okay.
4 down to 0 sum. Okay, here sum should be 4 down to 0, because if I am adding two 4-bit number, I will get a 5-bit sum. So 4 down to 0
Mm.
sum. Okay. So let's end the class. Okay. So now here, here I have not declared sum as a rand, because sum is the output I will be getting from my duty. But input random number I need to generate. So here you must be write rand or rand C. If you are not writing rand here, then you cannot create the random numbers. Okay. So
Mm.
now here you can write a display function. Function function void display string VLSI class name, then dollar display percentage s class name, then dollar display input 1 equal to percentile d, input 2 equal to percentile d, sum equal to percentile d. This is to display the values. Okay, whatever the values I'm generating, output I'm getting,
Mm.
I can write those inside the driver or monitor also. But here, if I'm
Mm.
writing inside this class, then I can use this code or this function inside driver or monitor class also. It is like reusable. I just have to write
Okay.
only one function. Okay. So now see,
Mm.
here I am writing this function display. But in UVM, there is a print function to
Mm.
print all the things. Means then it is already predefined. You just have to use it. But here you have to write your own function to use it. Now transaction class completed. Here if you want to
Mm.
write any constants, you can write the constants here. Let a question is like you have to generate some even number or number. So you can write your constant here also. Next go to
Okay.
generator. Okay. Generator dot sv. So class generator. So in generator, what I have to do here, I have just declared the values. Here I have to randomize it, generate it, and send it to driver,
Mm.
right? Okay, so how can I send this data to driver? Through mailbox.
Mm.
Okay, so here I have to generate a mailbox generator
Okay.
to driver. Okay, then this is my transactor class transactor. So transactor TRAN transactor here. Here I am creating a object of this transactor class. Okay,
Okay.
function. This is the constructor. To this constructor, I am passing this mailbox G to D. Why I am passing this mailbox? Because this mailbox should be used by generator and driver. So I should
Okay.
use only one mailbox for generator and driver. If I am using two different mailbox, then generator will be placing the values in one mailbox and driver will try to get from another.
Um.
So there is two ways.
Yeah.
Yeah,
Mm.
either you can
Mm.
do this method or you can write inside another class. Okay, I will tell that one later. Okay, so you just go through these things. Okay, so function
Mm.
new mailbox D to D. Okay, so now this the D to D is D to D then and function. So whenever I'll be creating this generator object for this generator, automatically this mailbox, only one mailbox will be created for generator and driver. We'll see in the code. Okay. So function
Okay.
new mailbox completed. So next I have to generate the values. Okay. So
Okay.
task run, then repeat. That's 20 times. Okay. Begin.
Mm.
So here I have to randomize these values. Okay.
Okay.
Assert tr dot randomize. Okay, just 1 minute. Mailbox. So here I have to create the things. Okay. So repeat 20. Then
Okay.
assert transaction dot randomize. So now here I will call the display function. tr dot display. Here I'll be passing the string generator.
Okay.
Okay. So it will display whatever I have written. This display function will be called. It will display these things. Okay.
Okay.
So here instead of global display, we'll try to right. Okay. So now after this, I have to send this data to driver. So how can I send this data? The mailbox name is generative driver dot put. So what is the value I want to put? This transaction. Whatever the value is generated from
Mm.
here, I have to put these things.
Okay.
So this is like I am writing if that means I'm writing asset means if this is 1 means my randomization is success, then it will do these things. But if randomization is not success, then it will give me error. Else if
Mm.
SR.randomize if not SR, if dr.randomize begin, if randomization is success, then these things, else dollar fatal. It will give fatal error. Okay.
Okay, got.
So task run, then end task. Okay. Begin end, repeat begin, so repeat end, then end task. So in this repeat, I have to give some delay. Okay, no delay is also required because anyhow it is going to store in the. Okay, so this is generator class completed. So in generator, you just have to generate the data and send it to driver. Okay. So next we should go
Okay.
to driver. So before going to driver, I have to write the interface code because the interface I have to write the things. Okay, because I have to send the
Mm.
data to driver to like through interface. Okay, driver to DT. So now
Mm.
interface dot sv, interface INTA. Okay. See, here I am not writing any mode port or any clocking block. Okay, that mode port clocking block
Mm.
it is required for the mode port I can write here, but clocking block where there is a clock. Here there is no clock, so I am simply writing the interface only. Okay, so interface
Okay.
declare all the data like input output with logic. Next we'll go to
Ah,
drive. Yes.
okay. Is there any clock that time we will
Here,
generate the
yeah, here
clocking
there is
clock?
no clock. When I will be explaining you FIFO, there will be clocking. FIFO will take 2 days. Okay. So before I will
Mm.
explain you FIFO, you just remember what is the flow and in which block, like
Mm.
in driver, what I
Okay.
need to write. In monitor, what I need
Mm.
to write. In generator, what I need to write. Okay. So next we go to
Okay.
driver. Okay. So if you know these things, then
Mm.
there I just have to explain you logic. If you don't know,
Okay.
then I have to explain their flow and you will get confused. Okay.
Mm. Mm. Okay,
So
count.
class driver, then here interface is required, so virtual, what is my interface name? My interface name is INTF, so virtual INTF BIF means virtual interface. See, here simple I have written, I could have written like this, interface, this is my real interface, then this is the dummy name. But why I am writing virtual here? Because my interface is the static element. It is the static like module, and I cannot call this static inside a class. So to call it inside a class, I have to make it dynamic. So I am using this virtual keyword to make it dynamic.
Actually, you are writing here virtual and intf. That is interface name or interface instance.
Interface name, this interface name. Actually,
But ma'am,
see here I am
hello.
writing transactor. Hello.
Mm.
Here I
But
am
ma'am said if we are writing interface, virtual interface, that time you to give actual interface instance name.
okay. You see here it is transactor. So when
Mm.
I am creating an instance of it, what I am writing? Transactor tr.
Mm.
Now this is my interface. Now I want to create a instance of this interface. What should I write? Interface VIF, right?
Yeah. Mm.
Understood or not?
I understood, but Okay, you continue, Akka.
Okay, and before this you should write virtual. Okay. Now what
Hmm.
name tool again, can you tell me?
She said first we creating that interface and take some instance. Then that instance name here. If you are creating that virtual interface, that time here you give na int f.
Hmm.
Instead of that, we are giving that interface instance name.
Yeah, this is the, you can say this is the interface interface instance name or interface name. This
Okay.
INT if I have to create give. Okay. So
Okay.
now again mailbox, because a driver will get data from the mailbox drive. Okay. So
Okay.
now here function new virtual GIF, then mailbox G2D. Why I am writing these things? Because this again, see, in like your UVM we have that advantage that all things we are declaring using config DB, we set it and we get it. Okay, but here there is like no config DB kind of things. So this interface should be common. Which interface I am using for driver, same interface should be used by monitor also. So that's why when
Okay.
I'm using this constructor, I am passing this interface and mailbox as a argument. Okay. Else, if I'm not passing them argument, there is another way also. We will see that in next class. Okay. But today, just think why I am doing this in the environment class. You will understand. Okay.
Okay.
So now I have to write task run. Okay, to get the data from the generator.
Mm.
Okay, and
Okay.
send the data to the duty. So here also I have to declare that transactor transactor PR. Okay, so task run. So whatever the data G to T dot get. Whatever the data I'll get from the mailbox. G to T is my mailbox. Okay. That
Mm.
data I am storing in the transactor class.
One second. Okay.
Okay. Then I should send this data to DUT through the interface. So how can I send those data? This is the format. Okay. Now VIF dot input one. That means in the interface, the input one that is assigned to transactor dot input one. Next VIF dot input two that is assigned to transactor dot input two. That means whatever the data I got from mailbox I stored in the transactor. Okay. Now from the transactor I am passing to the interface. This VIF is my interface. Okay. To the
Okay.
interface input 1 and to the interface input 2. Now from here my duty will take the data. Now let's
Okay.
give some delay, #1 delay. Then take the output. Now see, output will be taken from duty to transactor class. I am just generating input. So transactor class input is given to duty. Now output will be taken from duty. Remember, so I can write here transactor dot sum equal to VIF dot sum. Means whatever the interface I am getting sum, that is assigned to here. And here it is, just see the difference. This is giving input, this is taking the output. Okay.
Okay.
So
This
this,
is the format for everything.
yeah, this method you have to write, like if input are 10 number of input, then you have to write. This is the main task.
Mm.
Okay. At which
Okay.
time, how you should give the input, all those things. So repeat 10
Okay.
because I am generating the data 10 times. So repeat 10, begin.
Mm.
So now let here you want to check how many like the data set generated or something like this. So you can write TR. dot display driver. Okay. Then end, repeat begin and then end class. Then end class. Remember, whenever you are assigning the input, use non-blocking assignment. Why? Because we want to process this at a time concurrently. Okay. So non-blocking
Okay.
assignment, when giving input, output, you can use blocking assignment.
Okay.
Okay. So
Akka in
drive.
8 line,
Yeah.
8 line one
Okay. It is.
VIF.
Okay. So now driver part completed. So next we'll go to monitors.
Okay.
Okay.
In SP test bench also we creating this monitor block and all.
Yeah. Everything is same. Just 2-3 blocks are different. So monitor,
Okay.
I can just copy paste these things. No, just write step by step. Okay. So class,
Okay.
class, class monitor, virtual interface VIF. You can give different name also. This name you can get different, but this name should be same as this name. Okay.
Okay.
Then I have to create a mailbox that is from monitor to scoreboard. Monitor to scoreboard also I need to send the data, right? So now run new virtual interface VIF, comma mailbox interface. Now this
Here we giving this using this thing. Six, 7 and 8. We are creating what we do here.
see, actually here what
This
I'm doing,
way.
see this name and this name are same, right? So the thing is that whatever the argument I am passing, that
Okay.
argument should be assigned to this value. Now as
Okay.
both
Okay.
are same, so I am using this pointer. Okay.
Okay.
So task run, repeat, then so here also transistor clear, repeat, then begin. Here is equal to new. Okay, so now here I will be getting the data from the interface. Okay, so now tr dot input 1 equal to interface VIF dot input 1. See, just I am getting the data from interface and storing it in the transistor.
Okay.
Here you can give a hash 1 delay here, because there also I have given hash 1 delay. So this is the problem with combinational circuit. Okay, so if we are using clocking block, then we don't have to give this delay. With respect to clock,
Okay.
I have to do all the things. Then M2S put here. So now I put the data through the mailbox. So now dr dot display Okay, next scoreboard. So in scoreboard, we just have to take the data from the monitor and check it. So
Okay.
mailbox, monitor to scoreboard, then constructor, mailbox, monitor to scoreboard, then this dot m to monitor to scoreboard is equal to then end function. Then task run. So here I have to take the data from the repeat 10 from the monitor. Okay. So here again conductor PR. So repeat 10 begin. Monitor to scoreboard dot get. I am getting the data from the mailbox and storing it in the transactor class. Okay. It is the object of the transactor. Okay.
Yeah.
Okay. So now I have stored the data. Next I have to check. Okay. So just display. Now I have to declare a environment.
Okay.
So in the environment, what I have to do, I have just created all the class, but I have to use them inside one class, right? I have just created, I have written this run, but where I am going to call this run function inside the environment. Okay. So every instance I am going to create generator G1, driver G1, monitor M1,
Mm.
server S1. Then two mailbox. One is mailbox generated to driver. Another mailbox monitor to scoreboard. Okay.
Mm.
So now next interface. Okay, so now here I am going to call it. You see, I first created G2D mailbox, created memory for mailbox, then monitor to
Okay.
scoreboard, created memory for this mailbox. Okay, then
Mm.
I have to create the memory for generator. Okay, so now here I am writing Z1 is equal to new G to D. Why I am writing G to D here? If I go to generator, here I am passing the mailbox as a argument. So which mailbox I am passing here argument? Okay, same I will be writing for driver. So D1 is equal to new. So first I have to give the virtual interface, that is VIF, then G to D. So now here same mailbox will be created for generator and driver. If I am not passing them as an argument, then different memory will be created for generator and driver mailbox. I want same mailbox should be created. Okay. So now monitor 1 is equal to new VIF, comma, here it is monitor to scoreboard. Now here see, same interface I am giving to driver as well as monitor. So whichever is common, that should be passed as an argument so that I can give the same. Okay. Then S1 equal to new. So here no interface required, only the mailbox. You see same mailbox to monitor and scoreboard. Okay. So now end function. Next I am going to call task run.
Okay.
So first I will call this G1 dot run. This is generator task. Okay. So after generator generates all the things, okay, then I have to call the task of driver, not main, D1 dot run. Then monitor M1 dot run. Now see, this driver is, it is sending the data to interface, monitor, it is taking the data from interface. Now they should work parallelly. It is not like the driver will send all the 10 data, then monitor will take the data. No, driver is sending one data, monitor will take one data. Driver is sending another data, monitor should take another data. So they should work parallelly. So parallelly means I can write fork join. Okay, after that part complete, then monitor will send the data, then scoreboard will check, then scoreboard can take its own time to process it. So then scoreboard dot run. Okay, then just git let hash 10 delay and gt, then dollar finish. Then end task, then end class. So next I will go to test. So inside the test I have to just call this environment. Okay. See, these things should be called inside a module, like inside a hardware kind of thing, either inside module or inside interface, because I cannot run simple task, simple class. I should use a module in order to get the result. Okay, so test.sp. So test we should be writing in program. In Verilog, we are writing using module. Okay, but here we will be writing using program. Why program? Why program block is used for test bench? For test.
Why we are using count? These things are ma'am, not teachers, I think.
Main has tool program block. See, program block means actually if my design is in module and in my test bench is also is module, then both are executed in the active region. So there is a race around condition. I don't know which one is going to execute first. If I am writing program, then program means just wait. Okay, is my screen still visible?
Visible.
SystemVerilog timing reasons. This is a important interview question. Why we are using test bench in my program? See, my test bench is executed in the reactive region. My module is executed in the active region. So they both are executed in different regions, right? These regions are added in SystemVerilog. These regions are in Verilog. Okay. So now as they both are executed in different regions, so there will be no race around condition. So through test I am passing this interface. Then here I am just creating environment envir envir environment, let E1, then initial, begin, E1 equal to new. Here I am passing this interface, INF. Then E1 dot run. Here I am calling the run function of the environment. Okay. See, if I am just writing inside class, I cannot run it. I have to write inside a module. Okay, here I can write module and module also. Okay, but in the system Verilog, wherever the race round condition between my design and my test bench, instead of module, I am writing program and program. So here my U1 run will be called. Okay, so now I have generated all the test bench. I am giving it to duty. So now I should have do the instantiation. Okay.
Mm.
So that is, you can say, top. Top means there I will be just instantiating my test bench and my design. So module
Okay.
top. See, it is not like in one day you will understand. Just practicing. Even if this adder code, we first try to
Mm.
understand the code I have written. Then without looking to my code, try to write yourself. Try for mocks also. One or two combinational circuit. Once you are acquainted with the flow, then move to sequential circuit.
Okay.
So module top. Then so
Actually,
here,
my voice is slow now.
okay, just wait. Now it is clear.
Not clear.
Okay, so module top. Then here I have to create INTF INF interface. Then I have to call test. So test T1. So to T1 I should pass this interface. This is my test. I am creating an instance of test here and I am passing it. It is like module instantiation. How we do module name, then dummy name, then a port. So here test, okay, that only I'm doing here. Okay. So after that I have to call this duty. Okay, so adder. I'm doing the instantiation as position wise. Okay. So first I should give inf dot input 1, then inf dot input 2, then inf dot sum. See, here I am not writing directly through the interface, I am giving the data. Okay.
Okay.
Then initial to check the waveform. Okay, initial begin dollar dump file header dot bcd, then dollar dump variables and module. Okay, so here I have just instances. So now see, these files are not included. You have to include those files here. Okay.
Okay.
So we can write a header file. Let header HEA header dot svh means system Verilog header file. Here you have to include all your files. Okay. So first include the interface. Why I am first including the interface? Because it is an independent component.
Okay.
Include interface file name. You have to write interface.sv. It is not dependent on any other. See, if I go to generator, my generator depends on this transactor. Driver depends on transactor. So I cannot declare driver first, then transactor. But my interface, it is not depending on anything. Interface, it is not depending on anything. Okay. So first interface, then transactor class.
Okay.
Static include transactor dot sv. Okay. Have I written transactor? Okay. Transactor or transaction class, anything you write. Then driver, sorry, generator, then driver, then monitor, then scoreboard, then environment, then test. So transactor, after transactor, then it is generator. See, you cannot write first generator, then transactor, because inside the generator you are using transactor class.
Okay.
Okay, after the generator, then there is driver.
Mm.
After driver, then there is monitor. Then scoreboard. Then environment. Then test. Okay. So now just I have to include this file here so that all the file will be automatically included.
Okay.
Take include HEA
Header.
header dot svh.
Okay.
Now let's see how many errors are there. 7 errors, 8 warnings. Okay, so warning leaflet cannot open generator. The header generator. Okay. Next,
Mm.
syntax error, environment SV2. Go to environment SV2. Generator G1. और 10 मिनट आड़े लगे मम्मी हाँ 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 ठीक है हाँ 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 what is the issue here? Unexpected token generator. Okay, sorry, I have done it because generator name I have written wrongly na, so it is unable to find what is this generator. Unexpected token G2T environment 13 G2T mailbox. Okay, here I have missed the comma. Next, instruction master brackets test bench 4. Okay. Only checker from sample compilations of program block. Test.sv3. Okay, VIRO EN VIRO 0 ONNENT. Fatal error. Where is the fatal error? Generator SV12. Generator. Okay, I have not created new. Fatal error means it's somehow related to
Mm.
memory. First one. Okay, you can see in the generator, I'm just generating the input. In the generator, I can't get the output, right?
Yeah.
See, just wait. See, here it is coming like this, na, generator input. This is due to this. I have written generator. Okay. So after this, let's give one tab. Sorry. Okay, so generator is just generating the values. Then driver, you can see I'm getting the output from driver. And driver and monitor are working parallelly. Right?
Uh,
Okay.
yeah, right.
Then after monitor, I have written the scoreboard. You can
Mm.
adjust their timing and make them to work parallelly, like generator, then driver, then monitor, then scoreboard. You have to write all the things inside the scoreboard. Sorry, inside here. In the environment,
Mm.
you have to write inside fork and join everything. Okay. And give the
Mm.
delay. You have to adjust the delay also. Now let I want to check the things. Okay, so inside the scoreboard, here what can I write? If tr dot input 1 plus tr dot input 2 equal to tr dot sum, then dollar display result correct, else dollar display. So now let you have here I have directly written addition. Let you have designed a RC ripple carry adder. So here there will be different logic. So you have to check here whether it
Mm.
is correct or not. Okay, so result correct. Okay.
Mm.
So like this you try mocks. First try to understand these things. Okay, then try with mocks. I will send this link in WhatsApp. Okay.
Okay, Akka,
You
okay.
first take there like 2 to 3 days to understand whole flow. If you once understanding flow means the sequential, you can do the things. But if you are directly going to sequential, there you will get confused. Why I am doing this manner. Okay.
Okay.
Bye.
Actually, ma'am explained me the test bench interface generator driver. Those things only she explained.
Okay.
Mm.
Actually, to know the whole things, you have to run them. Okay. See, in UVM also, I have written the UVM code, but still now I am unable to run the whole thing because I have just written up to scoreboard. I have to write all the things in order to get the output. Okay. So
Okay.
this is the
Mm.
flow, like first a transactor, generator, then interface, then driver, then monitor, then scoreboard, environment, test. Okay.
Okay.
This is the simplest example. Okay, you just understand this example and try to write the mocks. You once you are done, then tell me. I will explain the new things. What can we do more here? Okay.
Okay.
Okay. Bye.
Okay. Okay. Thank you, Akka.
Okay.